let's go ahead and take a pause for the cause. If we do that and we got this route map, what should happen here? Let's just take it one step at a time and process this route map fully so we fully understand what's going on. In today's lab, I'll be going over exam topics 1.2 and 1.6, kind of combining those. As I was studying and labbing it up, I found that they kind of go hand in hand. For 1.6, you got configure and verifying policy-based routing. And then for 1.2, you got troubleshooting route maps. Well, I noticed in policy-based routing, you're just using route maps to set conditions for packets to be forwarded. You also have to troubleshoot those route maps to make sure that the policies that you're setting are being matched and that traffic is being forwarded as you intended it to. And as you can see, we got road 2, road 6, road 5, road 3. This was really for me when I was studying. I was just trying to make it like a simple way to really understand this traffic and how it's flowing. So I thought it would just be easier to say, hey, if I want a certain type of traffic to go down road 2, I could just think of it like that, right? Instead of the link between S01 and S01, like that's too much to remember IP address. I could just say road 2, road 6, road 5, road 3 as I'm thinking through this lab. That just makes it easier for me. Let's go ahead and break down the objective of this lab and what we're trying to do today. I got R1 here. There is a loopback interface configured, and what I'm going to attempt to do is just telnet over to here because this is the only router that has telnet set up on it for this lab. And what we're going to do is I want that telnet traffic, I don't want it to go down road 6 or road 2, right? I only want it to take road 5. So I'm going to implement policy-based routing to say, hey, here's a policy, only take road 5. And then I'm going to verify. So configure and verify that. And then if it doesn't just take road 5 and it takes road 6 and road 2, I'm going to troubleshoot the route map that I got configured to figure that out. All right, so let's go ahead. Hopefully all that made sense. Let's go ahead and get started. First of all, I'll just show you all the connectivity and everything so you can see how that works. So we'll jump into R4. Again, the objective is to telnet from R4 all the way to R1. Let's look at some things right quick. First, let's ping the IP address we're trying to telnet to. And now let's try to telnet to it, 192.168.1.1. And we're in there, R1 from R4. Everything is happy, everything looks good. As we can see, we have 3 links on R3. 3 decisions. He can go road 2, road 6, road 5. Let's look about that a little bit closer in R3's routing table, right? So if we go here and we go show IP route, let's do 192.168.1.0, right? Road 2, road 5, and road 6. So all of that matches up. He has 3 options. Again, this is how it looks in the routing table, right? Look at that. You got 3 routes. 6, 5, and 2. What we want to do right now, our first step is to configure an ACL to match this traffic, that telnet traffic that's coming from R4. So what we're going to do is configure R3 to do that. First thing to do is go in here and we're going to go configure. Right here, let me give you the difference between access-list versus IP access-list. So let's look at them. Access-list, if you question mark that, and if you do IP access-list. As a CCNA, before I started studying for my CCNP, this used to always trip me up. I didn't know or understand the difference. There's no way for you to just delete a specific ACL entry if you're using the access-list command. If you're using an IP access-list command, there is a way for you to do that, to just delete a specific entry. And that's really the main difference besides this being legacy, right? Because here you have standard and extended IP access list ranges right here. But here it's a little bit more cleaned up, right? This is all legacy when they first started out, and then this is when technology caught up and everything like that. So you got extended here. You can specify, and we all know that that gives us different information when we set it up like that. But for the purposes of this video, let's go ahead and just drop this old school access-list. We're going to use 199. just a basic access dash list, a standard one, right? I'm sorry, extended one. And then we're going to go permit. It's extended because we're going to permit, or I'm sorry, we're going to specify a specific protocol. And with standard, you can only do source and destination IP address. We're going to permit 172.16.34.3, 0.0.0.7, the wildcard mask, going to any destination equals telnet. So let's go ahead and look at, we do a do show IP interface brief. As we can see, we have 34.3 is on S02, and that's the ACL. What we're saying is any traffic that's coming from this source IP address of 34.3, which is S02, we're going to permit it. If it's telnet traffic, we're going to permit that traffic to go through. Alright, so next up, after we match the traffic, now we have to configure a route map for the policy-based routing portion of it, right? So if you go route map here, we'll use RM1, and we're going to go permit 10. We could have left all that default because permit is the default action and 10 is the default sequence number. We're going to do match IP address because we're matching the ACL of 199 that we just configured. So again, I'll show you the options here. Match. Reason why I chose IP address, it's IP right here because it's the syntax, but to address match the address of the route or match packet, and then the ACL number is the last part of that syntax. That's just to match the traffic. Then you have to tell the route map what you want to do with the traffic that you match. If you leave everything default in a route map, as far as the match and the set statements, it's going to default to match everything and take no action on everything that's matched, which is basically nothing. It'll be doing nothing. So here we're setting IP next hop of 172.16.53.5. That next hop is this router because I said I only want to take road number 5. So what I'm doing is I'm pointing that traffic after it's matched down that road of number 5. And that's it for that part of it, which is just configuring the route map. Now we got to configure that policy. So once we go out here, we're going to go interface. I'll add this real quick. With route maps, you could use it for various different reasons. You can use route maps, which in a previous video, and I'll definitely give you a link to that. We've used route maps to filter out route and protocol updates. But specifically, if we want to do any policy-based routing, you have to apply a policy on the interface. When you're doing those route and protocol updates and you're filtering those, you don't have to. And that's something that I learned and I believe is really, really key to know about route maps and policy-based routing. So right here that we want to apply it to on router 3, again, it's going to be on this S02 interface. As this traffic's coming in, we don't want to apply it here because the default routing behavior, if we applied it here on one of these, once this traffic hits here, the route map's not even going to get processed. The route and protocol will just take that traffic, that telnet traffic, and whatever path is available, it'll shoot it down that one. So we don't want it after, we want it before the router gets that chance to process the route in the routing table. We want to put the policy here. Hopefully that made sense. So let's go ahead and drop that policy right there. We're just going to go interface S02, set, oh, I'm sorry, not that, IP policy, then route map, and then the route map that we created, I'm sorry, was RM1. So now we have policy-based routing configured. So now we just need to verify that. To verify it, we do show route-map. We can verify that we have a match clause here and a set clause here. The match clause is, like I said, matching that ACL. Set clause is setting the next hop to road number 5 or router 5 in our example. Now all we have to do is test that policy. Let's go ahead and take a pause for the cause. If we do that and we got this route map, what should happen here? Let's just take it one step at a time and process this route map fully so we fully understand what's going on. So since we configured the policy on the interface, as soon as the traffic hits, the route map will start to begin to get processed. The first sequence says to permit, which means allow that traffic. What traffic do you want to allow? We're matching IP address for the ACL of 199, which is that telnet traffic that's coming from R4. What do we want to do once we identify that traffic? We want to send it down and forward it to the next hop of that. Once I hit telnet here, it should go through. Also, this is very key. If the traffic that hits interface 2 doesn't match any of this, the default behavior for a route map is that it is going to have a permit. Just think of the next line would say route map RM1 permit sequence 20, and I would just have blank match and blank set, meaning match anything that's coming through, any kind of traffic, and do nothing with it. So it'll just process it, meaning it'll just go back to default to normal routing behavior. Once it hits this route map, the traffic, it doesn't do the default route behavior. It does whatever the route map tells it to do first. And then after it's done, then it will go ahead and go back to that default route behavior of checking the routes and the AD, the administrative distance, or what have you, right? So let's go ahead and test this policy. And we hit telnet and it's open. Let's put in our top secret password of Cisco there, and we're in. So exit, and here we go. Now let's look at our route map here. What we want to pay attention to is this counter right here, is the policy routing matches. This will verify our policy is working. So as we can see, we now, instead of 0 packets, we have 23 packets. So we know that this process is working and our config is, everything is operating as we designed it to. However, what we need to look more closely at now is if this policy is really working, and is it truly getting what we want to accomplish here. So again, I only want it to take road 5 and not road 6 or road 2 for whatever reason. Now let's go ahead and test this route map and troubleshoot the route map and this policy-based routing by shutting down this link between for road 5. Let's go ahead and look at that and see what that does. So if I go here, conf t interface S03, we're going to go ahead and shut that down. So now that that's shut down, if I was to telnet from R4, from all the way over here, down this way, what now do you think would happen? Do you think that it would still go through? Because we do have the route map and everything. So let's look at our route map. Nothing's changed with that. No new packets have gone through. So let's go ahead and test that out and see what happens when we run that telnet command, because what we desire to happen is that it doesn't take road number 5. I meant that it does nothing, that it gets discarded, right? It doesn't take road number 6 or road number 2 since our link is down, right? So telnet, and we're still getting through. The question we have to ask ourselves is that policy really working? So if we go back and look at it, it's definitely working because the packets are incrementing, but it's not getting us our desired outcome because we want that traffic to be discarded. We want it to go away if this link goes away. We don't want it to take road 6 and road 2. So just like I said before, this is what you have to understand, and hopefully this drives the point home of how route maps happen, or how route maps process and how they work. Once that traffic, that telnet traffic, hits router 3 and invokes that policy for this route map, the default routing behavior goes away. But remember, let's look at our show IP route again. This is our routing table. We still have an EIGRP routes to that destination network through road 6 and road number 2. What's happening here is this hits here, it matches it, it forwards it down to R5, and then what happens to the traffic that wasn't that wasn't destined for R5. The default routing behavior kicks in because after this gets processed, the next statement is to allow all other types of traffic. So the traffic that didn't get processed, that didn't get sent down R5, it gets to go to 6 or 2, whatever path this router makes a decision to forward it down, and it continues on. So, well, what we can do, which isn't ideal, what we should really be doing is filtering the traffic with ACLs, which is way more efficient and way more cleaner, way more easier to understand and break down. But since we already have this route map in place, what we can do is we can go here and we can apply a policy on this interface down road 6 and on this interface down road 2 that will discard any telnet traffic. So once R3 results to that default behavior and tries to send it down these guys, we'll have our route map policy say, hey, no, we don't want that to happen. For us to do that, we have to go back into R3 and go back into our route map. And that route map was RM1. And what we're doing right now is called configuring multiple conditional matches here. So what we're going to do here is we're going to go set tag 199. So in this route map, hold on, actually, let me get out of here. We're going to have to go into the route map, the same route map, but under a new sequence number. So we're going to go permit 10. Then we're going to go set tag 199. So what this is telling the router to do is create a new sequence number 10, because we already have one, but it's saying no, create a new one. So this will probably now be 20, right? This will move down to sequence number 20. Or I'm sorry, no, we're going into sequence number 10 and we're adding a set clause to sequence number 10. So once we do that, let's go ahead and configure that. And now let's go ahead and verify that with do show route map. Set tag 199. So now we have two set clauses in here. Once it matches access 199, it's just going to tag it with a number 199. Again, reference my previous video on troubleshooting suboptimal routing for more information on tagging with route maps and troubleshooting that. But once you tag it with 199, we're still going to do the same thing. Just set that next IP to 5, right? Now the next thing after that, what we want to do is we also want to create another sequence. So let's get out of this sequence right here, number 10. We're going to go route dash map RM1 permit again, and this time sequence 20. What are we going to do here? Well, this one we want to match that same ACL, but what we want to do here is set interface to null 0. What this does is say, hey, anything that matches that, I'm sorry, not match that. Let's put no match IP address 199. We're not matching the access list. We're matching the tag traffic of 199. Remember, we're tagging that traffic of 199, which is referencing that ACL. It's not referencing, it's just a number. I'm sorry, it's just a number that's tagging that traffic. But what we know that it's coming from the previous sequence and that it's matching that IP address or the access list 199. So we want to match tag 199, and then what we want to do right there is set interface to null 0. And again, this just says, hey, if any traffic has this tag of 199 and it's coming through this route map, I want you to send it to the interface of null 0, which is a virtual interface that just black holes or just discards any unwanted traffic. So now we're not finished yet. Hopefully all that made sense. Still have to apply this policy. And where did we say we were going to apply it? To S00 and S01. So we can come in here. Let's just do interface serial 0/0. And then we're going to do IP policy route map RM1, and then we're going to do interface S01, IP policy route map RM1. Now we're going to go test this policy again. Now what do you think is going to happen when we try to telnet to 192.168.1.1? First, before we do it, let's just look at what we got configured and kind of run through it. All right, so we got a permit sequence 10. So this is the first sequence in the route map. It's gonna break out of its default route map behavior and say, hey, this guy wants me to match access list 199. So that telnet traffic coming from router 4. Then this guy wants me to tag that traffic with the number 199 and then forward it down to 5. Then also it wants me to match any traffic that's been tagged with 199, which it was earlier, so that fits the criteria. He wants me to send it to this black hole interface of null 0. What should happen is when we telnet over there, nothing should happen. So let's go ahead and do that, because remember, we still have that interface down on road 5. Trying, and it finally times out and fails. And if we really wanted to get jiggy with it, we could verify it through the route map. And as you can see right here, we have 3 packets that match this sequence number. Alright, y'all, that pretty much wraps up this video. I hope everything made sense. If you found any value, please like, comment, share, subscribe, do all of that stuff. Get them algorithms turned up for me. Turn my channel up for me. I appreciate each and every one of y'all. Y'all catch me on this next video as we continue down this NRC journey. Holla at me.